And this rectangle, after cutting off the cutting off the squares, you are folding it to make a cuboidal box with an open top. Okay, you're cutting out the squares from the four corners. Okay, and the question here is what should be the side of each of these squares that is to be cut off, and what is the length of breadth of this rectangular sheet given? It is 45 centimeter by 24 centimeter. Okay, you need to find out what should be the length of the square that I need to cut off. So what I say is, let each side of the square be x that we are cutting off. Okay, I say let each side of the squares cut off from the four corners of the rectangular sheet bx. So here x is a variable. Okay, so now what is the length that is left here? What is the length of this box here? Length of the cuboidal, this should be the length. What is this length here? 45 minus 2x, right? What should be this length here? 24 minus 2x, right? So these two, if you see, this forms the base, right? Which one forms the height? This forms the height of the box, right? So length of the box, (45 minus 2x). Breadth of the box, (24 minus 2x). And what is the height of the box? Is equal to x. So therefore, what should be the volume of the box?
Volume of the box. Length and the breadth into height.
Which is equal to x into 45 minus 2x into 24 minus 2x.
24 minus 2x.
Let us call this v. Okay, that means v is equal to, if you multiply, you will get 4x cube minus 138x square plus 1080x. This is the volume. Okay, let's first find out dv dx. Therefore, dv dx is equal to 4 into 3x square minus 138 into 2x plus 1080, which is equal to 12x square minus 276x plus 1080. So now from this you can take 12 common to get x square minus 23x plus 90. Okay, you can factorize this because we are going to equate this to 0. So if you factorize this, it will be better. So this will be x square minus 5x minus 18x plus 90. 12 into x into x minus 5 minus 18 into x minus 5, which is equal to 12 x minus 5 into x minus 18. So for maximum or minimum v, we have dv dx is equal to 0. That means 12 times x minus 5 into x minus 18 is equal to 0. That means you get either x is equal to 5 or x is equal to 18. Okay, so for these two values, you need to check the sign of the second derivative. Let's first find out the second derivative. d2v, therefore d2v dx2 is equal to ddx of dv dx. This is ddx of, now dv dx, which one should you take here? dv dx, let's take it this here, 12x square minus 276x plus 1080. Okay, so now if you differentiate this, you're going to get 12 into 2x minus 276, which is equal to 24x minus 276, which is equal to, now you can take 12 common here to get 2x minus 23. Okay, so at x is equal to 5, d2v dx2 is equal to 12, 2 into 5 minus 23. Okay, which is obviously less than 0. So at thus v has a point of local maxima at x is equal to 5, right? Also check at x is equal to 18. At x is equal to 18, d2v dx2 is equal to 12, 2 into 18 minus 23. Now this is what? This is positive. Thus v has a point of
Minimum.
local minima
Or minimum.
at x is equal to 18. Now we want to find out which one? We want to find out the maximum, right? So that means we'll take x is equal to 5. So what is the maximum volume? Okay, we just need the side of the squares, right? We just need this value of x. Hence side of the squares that need to be cut off. Hence side of each square that needs to be cut off from the four corners so that the volume of the box is maximum possible. Is how much? 5 centimeters. And that should be your answer. So you need to cut off 5 centimeter from, now if they ask you about the maximum volume, what should be maximum volume? Maximum volume, V max. Put x is equal to 5 in this expression. In the expression for V, put it here. So you get 5 into 45 minus 2 into 5 into 24 minus 2 into 5. Okay, so you get the maximum volume as 2450 centimeter cube. Okay. Any question? Otherwise, we can move on to the next problem. Okay. Now we come to, I think, a problem where surface area of a box is given to you. Let's see. Read this problem. Show that the surface area of a closed cuboid with square base and given volume is minimum when it is a cube. Okay. So you have a cuboid with a square base. Okay, this cuboid has a square base whose surface area is given. So here's surface area. Okay, volume is given, not surface area. The surface area of a closed cuboid with square base and given volume is minimum. So S, the surface area needs to be minimized. Okay. So here I say, let each side of the square base be X. And the height of the cuboid PH. So which ones are your X? This is your X. This is also your X. And which one is your H? This is your H. Okay. Now the volume of this box is given to you because show that surface area of a closed cuboid with square base and given volume. Okay, given volume. Yes. So volume of the box is equal to V given. That means V is constant. Here, X and H are variables. Therefore, what can we write? What is the expression for volume? X into H, which is X square H, right? Let us call this one. Now we need to minimize which one? We need to minimize the surface area. So what should be the surface area of the box? If you remember the formula for surface area, what was the formula for surface area of a cuboid? Twice L into B plus B into H plus L into H, right? L into B is X into X, give you X square, plus B into H, which will give you XH, plus L into H, which will again give you XH. This is the surface area. So that means you can write S is equal to twice X square plus 2HX. Call this 2. But S we need to minimize s, but s has two variables here, h and x. We need to bring those two down to a single variable, right? So from 1 we can find out h, v by x square. So putting this value into, we get s is equal to twice x square plus 2 h x. That means you're getting s is equal to twice x square plus 2v by x. Okay. So therefore, now s is down to a single variable. So we find out ds dx. ds dx is twice 2x plus 2v into minus 1 by x square. Okay. So you can take 2 out to get 4 times x minus v by x square. For maximum or minimum s, we have the first derivative must vanish. ds dx is equal to 0. That means 4 times x minus v by x square is equal to 0. That means you have x minus v by x square equal to 0. X is equal to v by x square. That means x cube is equal to v. That means you're getting x is equal to v to the power of 1 by 3. So at this x is equal to v to the power of 1 by 3, surface area is either maximum or minimum. So now we check for second derivative. Therefore, d2s dx2. ddx of ds dx. ddx of ds dx. What was the expression here? Expression here was 4 times x minus v by x square, which is equal to 4 times 1 minus v into minus 2 x to the power of minus 3. Okay. So you get here 4 times 1 plus 2v by x cube. Okay. So at x is equal to v to the power of 1 by 3. What is the sign of d2s dx2? 4 times 1 plus 2v divided by x cube. What is the value of x cube here? V. And when x is equal to v to the power of 1 by 3 obviously means x cube is equal to v. This cancels. So what is the sign here? Sign here is positive, right? So thus S has a point of local minima. At x is equal to v to the power of 1 by 3. Okay. And what is the question here? Once we have found out the local minima here, the question here is show that the surface area of a closed cuboid with square base and given volume is minimum when it is a cube. That means you have to find out all the dimensions of the cuboid. So length and breadth you have got here, right? X. So from 1 V is equal to x square h, right? That means V is equal to x square means V to the power of 1 by 3 square into h. That means V is equal to V to the power of 2/3 h. That means h must be equal to V by V to the power of 2/3. That means h is equal to V to the power of 1/3. So you see that x is also equal to V to the power of 1/3 and h is also equal to V to the power. That means length, breadth and height are all equal to V to the power of 1/3. That means it must be a cube. Hence, surface area of the cuboid is minimum possible when length is equal to breadth is equal to height is equal to volume to the power of 1/3. That is when it is a cube. Any question?